Although I think I can see it naman. Game? Are we on? Okay. Right. Okay, let me just fix some things. All right. Okay. So we're live. Good evening, guys, and good evening, people, and welcome to Accenture's first tech webinar for um, for the next few months. And this is a series of webinars that we are going to conduct on a variety of topics, mostly introductory ones. And the goal here is to get people started with various technology topics, get their feet wet on a few things that they might want to try out. Since we're trying to see if I mean, taking the first step in anything is always the hardest. So this series of webinars is meant to give you or to help you along those first steps. And our first webinar will be about building your first Android application. There will be others on a variety of other topics. But for this one, we are going to go through the different steps or the a very, very high level introduction on making or building Android applications. So now we will uh, go through the different steps and the different tools that you'll need to do. It will have some programming involved, but this is not a an in-depth guide on anything on the programming language used or the SDK, but this is just enough to get you started and to help you point you along the right direction. Okay, so so if I'll share the let's get to it, and I'll share the screen. So wait, let me just do that. All right. So wait, before that, I'll actually share. Uh, Hold on. Let me see if I can share the sites. Okay. So your first step in developing Android applications start here in these two sites. Um, the first tab here is where you download Android Studio. Android Studio is the Android team's Google Android team's official IDE or integrated development environment for building Android applications. There are other ways, there are other tools that you can use, but this by far is the most comprehensive and the most officially supported of the different tools that you can use. So if you're going to start, if you want to start learning how to build Android apps, Android Studio will contain all the tools, software that you need to get started. After that, your other reference site that you need to go to is the official Android developer site. Okay, so this is where you have information on building different kinds of Android apps, sample code, tests, references on the different libraries, and official guides, which you can use to learn more about developing Android apps after you visit. So I highly encourage you guys go to this site after if you're interested in pursuing more in-depth knowledge on Android. So how do we actually begin Android? I'm going to show you a simple application that I'm going to walk you through building step by step. Okay, let me just again share my emulator. If I can, let me see. It's not. There you go. So this is the official Android emulator, and you'll find this as part of the. Um, I hope you guys can see it. This is part of Android Studio. So if you download Android Studio, you will get access to a very robust and very flexible Android simulator that you can use to build and test your Android applications if you don't have your own phone. So it's a fully featured app. It's a functional Android instance. It behaves reasonably well. Okay, so you can test notifications, you can test apps, everything. So this is your go-to tool if you don't have an Android app or an Android phone yourself, but you still want to try out. There's also the thing that you can use to um, actually see the latest releases of Android. So if your phone's not being updated because you may have an older phone, Android emulators actually have they actually release the official builds here. Now, what are we going to build? So we're going to build a very simple Android application. So this is it. Just has a label, just has a couple of buttons, and then I'm gonna teach you how to make the UI react to a button press. Okay. This, okay. So, um, okay. So switching to the IDE. Okay. So if you've downloaded and installed the um, official Android Studio, and then you create a project. So I'll walk you through. I'm not sure if you can actually see the prompts. Okay. This is what. Wait, hold on. Okay. I hope you guys can see the prompt. Not sure if it's being set as the. Hold on. Sorry. Let me start that over again. Okay. So this is the project creation screen, and we're going to go through the creation of a very basic project. So we won't choose. It'll be an empty project, so I won't have anything in it yet. So I can walk you through this step by step. So you first select a new project, click next. You give it a name. Let's call it Hello World, Hello Android for now. You give it a package name, which is if you guys have Java experience, this is basically the Java package name. Location where you store the files, and then you choose a programming language. Now you have two options available here. You can use Kotlin or Java. Java being what the original language it was first chosen for official language for building Android apps. The past 2 years have added support for Kotlin as well. And my recommendation is if you are going to start learning Android applications or building Android apps, might as well use Kotlin. The two are compatible, so you can easily switch between Kotlin and Java code. But in the spirit of learning something new, let's just go for Kotlin. Minimum SDK here, very important selection because this tells you the minimum Android version that your application is intended to support. So as you can see, the lower the version, the tendency is the more devices that your app will likely run on. Later versions, because Android doesn't update as often, in a lot of devices, they tend to have much lower support. So if you want your audience to, if you want your app to reach as wide an audience as possible, you select the lowest Android version possible without sacrificing features, of course. So right now we'll choose 5.1 Lollipop, which gives us coverage of maybe over 90% of devices. We'll click finish. It creates the project. Oh, I actually did not. I think I have to reshare. Okay, here. Okay. Okay. So I will walk you through what creating an Android project actually gives us a bunch of stuff in the project by default. So there's nothing here yet. This is as bare bones a project as you can get. So you have your source code here. So this is where the actual code comes in. So it's still named Java, although we're going to use Kotlin in this example. We are there's a bunch of resource files. So under the rest folder, these are non-code stuff that your application will need. So things like icons. Okay, so and then there's things like colors, strings, and styling that we'll use later. And then you have your build files, these Gradle files over here. I'll go through all of these things in some detail as we build the application. So let me open another project. Okay. So what's the first thing that we want to do? We're going to open AVD. Sorry, I just realized that since I'm opening so much stuff and I'm sharing one screen at a time, you may not be seeing everything. Okay, again, apologies. I'll need to share something else again. Okay. So the Android Studio allows you to create a virtual device. I already have one created here, and this is how you get access to that emulator that I showed earlier. So it's a simple matter of creating a virtual device. I'm not sure if you're seeing everything. You pick screens, and then it shows up here. So, and then if you run this, it will launch that emulator that I showed you earlier. Okay, so back to the IDE. Okay. So just keep posting questions. Just keep posting questions on the board. I'll try to get to them as soon as possible. Or we'll set some time after this event to sorry after this so that we can go through your questions. I'll make time, promise. Okay. So let us begin first by putting something which is relatively recent to Android, and this is called view binding. I'll explain what this does later, but this was a convenience that was added to Android fairly recently. And if you've had some experience building Android apps before, you'll see what this actually enables. Now, I'm going to create a new activity. It will be an empty activity for now. Sorry, let me just pause for a bit. My ID is opening a lot of dialogues, and I want to make sure you guys can see it. Let me just talk to the team. All right. So I hope you guys can see. Right. No. Sorry, I think I do need to shift it. Anyway, so this is going to be slightly annoying, but I'll need to be shifting things or shifting sharing around so I can show you the stuff. Now, this is the dialog window for creating a new activity. Now, what exactly is an activity? You can probably guess from here, but an activity is the component that actually creates your user interface. So it's there's other components that you'll need to be aware of, but for now we can just stick with an activity, and this is where we'll build our user interfaces that we saw earlier. So main activity generates a few things. Main activity, which is this is a Java or a Kotlin file or a Java class or a Kotlin class, where we'll put the code that we need to write so that the activity or so that the UI can respond to user and system events. Then it also creates a second file. This is an XML file. I'll rename it because it's just a naming convention I like. Activity. And this is an XML file that this is where you design the activity, the UI itself. Okay, we'll click the tab here to make it a launcher activity. Now, what does a launcher activity means? It means that when you install this application on your phone, this is the first screen that will pop up when your users click the icon of your application. So if you don't set it as a launcher activity, it won't show up in your app drawer. So tagging this as a launcher activity will make this will make it show up in your app drawer. So if you finish this, okay, sharing again because it disappeared. Okay. Sharing, sorry, this is now, this is what it creates. So on the left side here, you have an activity class, and on the layouts, you have main activity XML. So it's an empty layout right now. There's nothing there. Okay. Now, one interesting thing that you'll need to see is that if you click on Android manifest, so it added this entry here. Okay. The manifest is one of the is basically a list of the different components that you've added into your Android application. So if you have several activities, if you have several screens, if you have background services, if you have receivers and data and content providers, those are things that store data. You'll need to put them here. So normally you can write this you can write entries in the manifest manually, but the IDE actually automates that for us. It's one convenience that the IDE provides. So this is an activity, the one that we just created earlier, and this is when it was tagged as a launcher activity. So putting this here makes it available in the app drawer so that the user can launch it. Okay. Now let's go to the layout. So it's empty right now. What we can do is we'll add just a simple label to it. So we'll add a text view. we need to constrain it so that it knows where in the screen it is. So this puts the text view. A text view is just a label, so it's a read-only label. And let's make it a bit larger. Okay. And we'll make it say hello. Okay. So that creates our activity. We are going to build this application. So build and run. So this, well, you can here. Okay. So installed successfully. Hey, okay. Let me again. Sorry. Switch sharing. Should probably share my entire desktop, but it might slow down. Okay. So this is the result of that first few steps that we just took. We, from an empty project, we created an activity. We set that activity as a launcher activity. Let me close this application so that you can see it being launched. So okay, so this is it. Our app is named Hello Android. So it created this application, and because it was tagged as a launcher activity, you can see it in the app drawer. You click on it, and then it immediately brings us to the activity that we created, which just says hello. Okay, I'm going to change in my ID. You won't see it to Hello Android so that you can see it update. And here, okay, all right. So that's a very small first step in creating an Android application. But let's actually make it do something now, so that it's not just a static application with just a single label. Right. So let's share my ID again. Here, am I sharing the right one? Okay, there you go. So a few things that you need to see, that you need to take note about this. Every UI element in Android has a label. Sorry, has an ID. So in this case, the ID here is text view. We can change it to something more descriptive. So let's call it main label. Okay. Now, how do you access? So you may have other elements in your application. So let's say, let's put a button over here. We connect it, so that it knows where that button should reside. Okay. And you'll see in the layout that it created another button. There's an error there because there it is. And let's give it some space. Okay. So modifying it here can do that. So this is a very robust layout editor. So as you can see, it's a lot easier to design Android apps now with this editor, with this layout designer than it was before. Before we had to do a lot of these things manually and sort of almost imagine what it would look like before it would actually render on a screen. So here you have a blueprint view that is actually a relatively accurate facsimile of what the app might actually look like. Now, how do you access these elements in your code? So we go back to the actual activity class. Remember, we were just talking about the layouts. But it also created for us a class. And if those of you who know Java, this might look somewhat familiar but different at the same time. So this is how Kotlin code looks like. Okay. Now, what do we need to do? How do we access that label and that label and that button that we had there earlier? Now, we need to do something called binding. Okay. So if you remember earlier, I enabled something called view binding here. This is what generated this class. You may be wondering. So this is a variable declaration in Kotlin. So if you're used to Java, it may seem odd because the type is after the colon and the variable name. Unlike in Java, where it'd be main activity binding, the class type, then the variable name. Now, what generated this class? What generated this class was the view binder that we enabled earlier. This allows us access to all of the elements that we defined here automatically. Previously, what we used to do in the earlier days of Android programming was we'd have to do manual find view by ID calls over and over again, and this was very annoying and also prone to mistakes. So this is this binder allows us to have access to all of those UI elements in a type safe and a null safe way. We are guaranteed that anything I can access in the binder is actually present in the layout file. So what do we do with the binder? We initialize it because it's not yet initialized. Main activity binding inflates layout inflator. Okay. This gives us access to the elements. How? So binding dots. So as if you can see these two things here, button and main label. So button and binding dot, oops, typo. Oops, binding dot main label. There. So once we have access to them, to those two views in code, then we can manipulate them. So for example, I am going to do a quick build to change the, wait, we need to set the layout first. Binding dot root. I am going to change the text of the label to hello binder. I'll run this quick and I'll show you the results later in code or in the emulator. Okay. So again, switching. Okay. So that's one way. So I've now programmatically modified the value of the label in the Kotlin class rather than just the design class. So let's change it again quickly so that you can see, and I'll compile from the background. Okay. Now, so I just realized we're running a bit short, so I will just switch to the more complete code that I'll just walk you guys through. Here. So what am I doing here? So it's pretty much the same thing. I defined a variable counter 0. I created a formatter. If you guys are familiar with C or Java, this is a way to format variables into a string. And then here in the button, I created an event handler or an on-click listener. So that means that every time I click the button that was on the screen, this code will execute. And what this does is that it creates a it increments the variable and then it sets the value to that. So it's going to show up count 1, 2, 3, 4, 5, etc. Let me show you quickly. Actually, So I have that already running here, and that's the previous app. So okay, that's what's happening there. So every time I click on increment, okay, this was the button. The method, the event handler for the button will execute, and inside that code it will sorry, I apologies for switching a lot. I didn't realize I'd be switching this much back and forth. So every time that button was clicked, this is the button, it executes this code, which increments a variable and then sets that variable as the text of the message. This next one here is really a way for us to just move. If you have more than one activity, in this case, I have a second activity, right? Which doesn't really do anything. Its layout is just an empty layout with the word second activity over there. And if you check the manifest, it's also there. So this it. There's nothing inside it because it doesn't really do anything. But and unlike main activity is not a launcher activity, so it doesn't show up in your app drawer. So I set this class to handle two events. One is the increment, and the other is another event handler to start the second activity. And this is what allows me to move from one activity to another. So if I have two screens in my app, this is one way that you can move from one screen to another screen. There are other ways, more efficient ways, but for the purpose of this basic application, this is how you do it. Again, so let's go through the app. Okay. So increment, increment, increment. I click on next. It shows the second activity. I click on back. It goes back. Now notice that it's still 60. So if I click on next, this is the second activity. If I click on back, this is still, it retains the state that it used to have or that it had before I moved to the second screen. Why is that? You can think of when you move from when you start one activity to another, by default, they act like a stack. So it's almost like you're placing each activity. Think of each activity as a deck of playing cards. The first activity is the one at the bottom, and every time you start an activity, it adds a card on top. And if you start another activity from there, it adds another card, and so forth, so forth. And whenever you press back on your whenever you press back on your Android phone, it removes or it pops the activity that's on top, so that the one at the one at the bottom of that is shown. And then if you click on back when there's just one activity left, it shuts down the application. Okay. Now so this is it. Let me just quickly recap what a very straightforward and simple what a very basic Android application looks like. Right? So you have a project with a bunch of Java or Kotlin files. This represents the code of your application, and this is where you will actually write the behavior. You have layouts. This is where you design your UI. Okay, these are XML files. Sorry, wait. I just realized I'm not sharing. Okay. So you have code. In this case, we have two activities, and this is where you define the behavior of the user interface. You have layouts. This is where you design the user interface. Then you have other elements here like colors, strings. So the default colors are all listed there. Again, you can change them as well. This is You can have strings as resources as well so that you don't hard code stuff in your app, which is always a good practice. Then you have styles and themes. So that's essentially a 30-minute, basically a 30-minute walkthrough of how an Android app is created. We barely touched. I don't even know if we've touched, well, like 1% of developing Android apps. This is a very quick overview. Um, uh, a very quick overview of how Android apps are built. So let me go through the questions quickly so that we can. Um, okay, wait. So wait, I have a bunch of questions here already. I will try to go through them one at a time. Uh, okay, so first question, newbie in Android development, Java or Kotlin? So this is a matter of taste. As a beginning programmer in general, you may have better luck with Java because there's like 20 years of history and material on Java and Java best practices that you can rely on. Not to learn not just Android development, but also other things that Java is used for. So back-end development, code, web development, all that kind of stuff. Learning Java is never a mistake. It will be usable for you beyond Android development. The reason why people gravitate towards Kotlin for Android is that you'll notice that if and once you learn Java, you can it's a bit verbose, meaning it has a reputation for being verbose, meaning it takes a lot of code to do something simple. Kotlin is a relatively younger language that was designed to sort of minimize the perceived weaknesses of Java, verbosity being one of them, right? But if you're just going to focus on Android, I highly suggest Kotlin. But if you're studying programming in general, Java is not a mistake. It will translate to beyond just Android dev. Can you adjust the phone's resolution to your liking? If you're talking about the code or the emulator, yes, you can change the display characteristics of the emulator. Um, if you're talking about programmatically like an app, can you have an app that allows you to change the phone's resolution? No, that's not available as part of the SDK. Is there an advantage for choosing the newer version? The advantage is newer versions that have a lot of fixes and a lot of features that may not be present in older versions. There are APIs in the newer SDKs, for example, more flexible VPNs, better security that won't necessarily be available in older versions. But you trade that off with potential hit in the compatibility of your phone. It's a fact that we've all lived with as Android devs that Android doesn't get updated very often for a lot of phones. So if you target a version that's too high, you may miss out a big part of your audience. How can I change the minimum version of Android if ever I want to change it? So you change it in the Gradle file called here min SDK version. The min SDK that's basically the same as your option earlier. So if you want to target a lower or higher version, then that's where you do it. Can we change API version? So that's the answer. So it's in the Gradle file that I'm showing you right now. First Android app, Java, Kotlin, cross-platform like Ionic or Flutter. If you're a previous if you just want to study Android itself, go for the actual Android SDK. Even if you're using Ionic or Flutter or PhoneGap or Cordova, you will eventually have to go down to the native Android code. So you can have a quicker start if you go for a cross-platform tool like React Native or Ionic or Flutter, and it will allow you to target both Android and iOS. But those platforms will eventually hit limitations that need to go down to the native Java or Kotlin code. So just study everything. Advantage of Kotlin for Java, I think I discussed this earlier with the so same thing. Just recall my answer to the first question. Performance difference between view binding to data binding. View binding was designed specifically to be performant. If you notice that it generates a binding code, a binding class. Previous third-party approaches to doing this was actually built on reflection, Java reflection, and anything that uses reflection is extremely slow. Now, data binding, you use data binding if you actually want. There's another use case for data binding, and it's with designing a more reactive type of UI. I can probably spend like 3 hours just talking about data binding. So, but for now, view binding, if all you want to do is just is you use it if you want to have easy access to your UI elements. RAM's capacity for well-responsive Android Studio. Yes, Android Studio is a resource and memory hog. More the better. I mean, don't even bother running Android Studio if you just have maybe like a 4 or 8 gig. 8 gig is fine, but it's not going to be very responsive. The main killer actually is the emulator. So I recommend a machine with at least 8 gig, and to run the emulator smoothly, you you use it you I recommend a machine with some kind of discrete graphics card, a GPU. What is Gradle and what is for? Gradle is Android's build framework. So it's like Ant for before and Maven. Build and dependency. It's the build system that brings together the code, the layout, the resource files, the third-party dependencies, and then builds them into a single Android SPK, Android APK that can be installed. Minimum specs, I answered that. I think else. Applicant responsive siya sa lahat ng all screen resolutions. There are techniques that you can use to make an Android application as compatible and portable and responsive as possible. And it involves it's a lot of different techniques that are held together. For example, using something called device-independent pixels when measuring your view elements rather than straight-up pixels, because pixels is not a very reliable metric to use when you need to support low resolution, high resolution screens or tablets versus phones and such. This warrants a bigger discussion, but yes, there are whole topics dedicated to making Android apps responsive. Compatibility if you use different mobile OS from the same application. Sometimes compatibility with mobile OEMs in general has always been a problem in Android, because the OS that's running on your Samsung phone is not the same build as the ones running on your LG or your Sony or your Google phone. Okay, so there are minor differences, and if when you start developing Android apps in earnest, you'll see it. You'll run into those problems. Efficient emulator Android device. Use a device if you want. If you have one, use an emulator if you don't, especially if you're trying to target a version of the OS that's not available for you on your device. Okay. How do you activate ViewBinder? That's in the Gradle file. The view binding enabled equals true. That's how you activate ViewBinder. Make an Android app with a database. If you're asking for an on-device database, yes. All Android apps have access to on-device SQLite. Swish at Android Studio. Not really familiar with Swish. I'll look this up. Different packages for different screen ratio. Not necessarily. You can create an Android app that can support both Android phones and tablets. And there are different techniques on how you would build the screens using fragments and such. How do you add graphic elements to apps like icons or screens? Icons, so graphic elements are views, just like text and buttons. So you can add PNGs to your resource files, drag them to your layout, and they'll show up there. Okay, sorry, I have to go. There's a lot of questions, so I'm trying to go through them as quickly as possible. Can you make a layout that fits all of the screen resolution sizes? So that's again something I mentioned earlier. There are a lot of techniques on making apps responsive, but in general, um, Android developers or Android layout designers use a concept called device independent pixel or DP, rather than using pixels themselves to when you're sizing. Can you explain view binding, data binding, and find view by ID? I'll go through this very quickly since it's our topic is UI. Without data binding, for me to access a text view, I would have needed to do something like this. So val text view is equal to find view by ID text view r dot id dot what was that? Sorry, r dot layout dot r dot where is it? I need to import this. R dot id dot something like message. Oh, I think it disables it. ID message, so it should be there. Something like this. Okay. And you're going to have to do this for every UI element that you have. So if you have buttons, you need to have. It was in older code, in code from 10 years ago, it was common to find dozens of lines just dedicated to find view by ID. It was extremely annoying, and it made already verbose Java files even longer. So this was very common before, finding this in Java code. View binding eliminates that because now everything is done automatically for you, and then you can access those view elements directly. So use them if you have them. You use them if you can. Can I transfer files from Java to Kotlin and vice versa? If you mean if they're compatible, like can you write Java code even though I set the project to Kotlin? Yes. Java and Kotlin both compile down to bytecode, so Java bytecode. So it's extremely easy. And it's a nice way to sort of soft transition to Android, to Kotlin. Recommended to use native software. Yes, use Android Studio. You can't use Xcode because that's for iOS. But yes, use Android Studio if you can. Risk by actual device. Yes, because for you to use your actual device, you're going to have to enable. You're going to have to set your device to allow installation from external sources, meaning not just from Play Store. If you forget to turn that off, you might find that you might inadvertently install applications that are unsafe on your phone. Upload to App Store just in case there's a sorry, you mean Play Store. So App Store is for iOS. There's an entire involved process for Google, but it requires you to have a Google Play account and a Google bank and a bank account that's linked to it if you want to sort of have it paid. Test application precision and speed. That's not really something that's very easy to test because precision and application speed is a variety of multiple factors. It could be based on your network, it could be based on what's currently running on your phone, how the spec of your phone and such. Not that easy to go through. Okay. All right then. I think I went through all of the questions. So again, I apologize for a lot of the screen switching. Next time, probably I just share my entire desktop so that you can see everything. But this is basically intro to Android, and I hope it was a very fast whirlwind intro, and I hope you enjoyed it. I hope you learned something from it, and yeah.
Can you please share the link again to the resources you shared at the beginning? I think a few people were not able to see the links.
Sure.
Thank you.
Android developer. Wait, is it E? Okay, do you want me to just? Okay, never mind. I'll just show this site. Okay, so this is the Android developer. This is your first step, Android developer, or developer.android.com, and then where you actually download Android Studio. Okay, here. So developer.android.com and developer.android.com/studio. I saw a question earlier about whether this is all that you need to download. Answer is yes. Before we had to download Java separately, the emulator separately. Downloading Android Studio will contain every piece of software that you need to start building Android apps. Okay. Okay then. So we're a bit over time. Um, do we still have time for questions? Or
Chuck, it's up to you. There are a few more questions that were shared, so I'm publishing them, and you can respond to them maybe last 2 minutes, and then we can end the session.
okay. Code in Python or Java, JavaScript. So there are two primary languages that you use when coding in Android. So it's either Java or Kotlin, but that's when you're using native Android code. If you're a web developer and you want to get started into programming in Java or building apps, you can explore things like Ionic or frameworks like React Native or even Flutter. Those are cross-platform tools, and they rely more on web-like tools or web-like languages to build Android apps. It's a good starting point if web development is your initial forte. But if you're starting out, the best way to learn everything that there is to know about Android is to go straight to the Android SDK, build native apps using Java or Kotlin. React Native over Android. So this is basically a question of using cross-platform versus native. Cross-platform, of course, is going to be very portable, meaning you can use one code base and then have a good deal of compatibility for iOS, for Android, sometimes even web and desktop. But the biggest problem with cross-platform is one, they will never be as fast as native Android code. And second is not every feature that you want may be available in cross-platform frameworks. And eventually you'll find yourself creating plugins on native code to get the feature that you want. And at some point for very complicated apps, you may end up having more plugins than the actual cross-platform code, so it might defeat the purpose. But for fast, simple apps that you want to target a wide audience, go for cross-platform stuff like React Native. That's fine. Okay. I think.
Thank you.
So,
thank you very much, Chuck. Again, our speaker for this evening is Chuck Lozada. He is one of our interactive leads in Accenture Technology. For those who would like to leave feedback, can you please go to menti.com and use the code 772392 to leave your feedback. We would appreciate hearing from you. We do have other webinars scheduled for the week. Tomorrow, the topic is blockchain. Thank you very much, everyone. And thank you, Chuck, again for your time this evening. Great talk.
Thank you. Hope you guys learned something. Bye-bye.
Have a good evening, everyone.